Okay, so how is everyone? I hope everyone is okay. I'll be taking you through APIs. And once again, my name is Bradley. So let's start our today's session. Okay, so I'd prepared a bit of slides to actually just get the introduction going, right? So we'll start with, I want to, how do I make this thing full screen? Oh, let me just deal with it later. Okay, so we are starting about APIs. So what are APIs, guys? We always actually hear this jargon, each and everyone telling us use this API, use that API. But what is an API really? So um, where the hell is this? Oh God. So actually, an API is a mechanism that enables two software components to communicate to each other. It's like a contract between two services to talk to each other or to exchange data, right? So let's look at one really uh, popular API that is used for sending money. So it's the Daraja API, Daraja API from Safaricom. Because Safaricom are also a payment service provider, right? They issue payments, they're regulated by the SABK and something like that. But how do they enable people from the e-commerce sites to make online payments without like having to do it physically through their phones? So they saw that need, they saw that demand, and they created an API to interact with their internal services for payment services, right? Yeah, so this is the link. Uh, so we'll move through and understand what an API. I believe that actually everyone has an idea when they came to this session of what API stands for. So it basically means application programming interface. So it's an interface or it's a contract, it's a layer of contract that allows two services to communicate with each other, right? Um, so we're going to also look at the evolution of APIs, right? We have to know a bit about APIs because it's not only the web APIs that are there, it's not only the traditional REST APIs that most of us create that are there, right? I don't know if there is, okay, there are questions. Okay, let's continue. Um, so, first of all, the most mature and the most oldest APIs are the SOAP APIs, right? They are simple object access protocols. They use the traditional XML format for data transfer, yes, and they are used by a lot of infrastructures like the banks because they are very mature and they were even before people started thinking of REST APIs. And they have a lot of shortcomings. That's why the REST APIs were created, right? And there are RPC APIs. These are remote procedure calls that allow two services to call one another as if they from different places as if they existed on the same machine. So a really popular RPC right now is the gRPC or the Google Remote Procedure Call. Yeah, we won't get into it right now, but just know that they exist and they're somehow popular and their WebSockets APIs, which open a WebSocket for you to, or they open a socket for you to communicate or to send data through that channel without interruption and doing the handshakes each and every time that you send it. They're good for streaming services, right? And real time services like chat features. And there is the one that we're going to focus on today, that is the REST API. So REST APIs are the most flexible and the most used types of APIs nowadays, rather. So actually, what is a REST API? Okay, all right. Let me just close this. So a REST API basically means representational state transfer. So what is representational state transfer? Because we actually create them, but we don't know what they do, right? So they actually just send everything over the HTTP protocol instead of relying on internal service calling. They use the internet HTTP protocol, right? And the main feature that makes them very good is that they are stateless. What does it mean by the word stateless? It means that there is no any type of um, there is no any type of storage of data when you call them uh, between the communications. Like let's say whenever you send a data to any REST API like Daraja Safaricom, you have to authorize each and every time. You have to attach a authorization and an authentication um, header and the keys each and every time that you send a call to their database or to their APIs. So they don't actually know who you are. And that's good because it can scale very well horizontally. You can deploy a lot of REST APIs on different machines because they don't need to cache any information within the API layer, but only in the databases and the caches. So they don't have to have a state. They just receive each and every user as long as they have the required headers and they process the information as they require. Okay, so what are the benefits? Because we see that we talk about the REST API so much, right? I think I talked about one, the integration. So integration with a new existing application is easier, and it creates a room for innovation because of how it is decoupled. So you can really create really complex applications, and expansion means that it can scale very well because scaling SOAP APIs is really hard because they inside inside the API, they store information about a user. So the user needs to finish first whatever he is doing before allowing another user. So just imagine that you scale it into two servers. So you need to also limit the number of users. How do you manage the user that is using this service to also have the advantage of using the other service or the other section of your code whenever this one is being taken or is being held by other people. So you see that it can't like really scale very well. And for maintenance purposes, it is very well because we don't need to actually put a lot of thought like we would in XML and write all the XML codes. But the funny thing is, REST APIs allow two ways of formatting and communication between data. That is, they also allow XML data and they allow the JSON format, which is the new format that has been really standardized by a lot of people. Um, so we're going to look a bit about best practices when designing a RESTful API before we even try to look at designing a RESTful API, right? So the first one is using the correct HTTP method. Actually, I see in a lot of people's code they use only two types of HTTP methods, right? They only use the get and the post method. But there are also other methods like the put, the patch, the delete. There are even other methods that I've not mentioned here that can help you, right? So we'll just have a look about the different types of methods. Let me just go to the Mozilla. Okay, I let's go to this link so that we can get a bit of overview about the other existing methods. So there is the get method that we all know. It gets the information and you don't have to pass in any field when you're getting data. You just get it. You don't pass anything because you're getting a resource from a certain place in a REST API. There is the head. There is the post method that is limited to adding something into our database because after the API layer, there is the database layer for storing the data that we need. So the post API is good for that. It submits an entity that causes a change in state or side effect on the server. So it actually stores something on the database. And there is the put method that replaces a whole entire line. Let's say someone is updating their profile and they are changing a lot of things, right? They are changing from their username, their numbers, their emails, and everything, even their images at the same time. We will be advised to use the put method because it is meant for that, okay? And there is the delete method and there is the patch method that is used for partial modification. Like let's say you want to just change your number. There's no need of doing a post method. And why do we need to use these other methods instead of just using like the post method? It does the job, right? But there are problems with the post method. The first thing is it is never idempotent. Idempotent means that whenever you do a post request, it will never cache itself to know that this request has already been called once or was called earlier, so we don't need to recall it again. Can you please mute your mic? Okay, so let's continue. So the idempotency means that you can send, let's say you have a problem in your API, for whatever reason, you're using your service, maybe you created a site like this, right? You have consumed data from the API and someone refreshes this page. Um, for whatever reason, there was a form that you needed to post. It will still post the same information twice, thrice, depending on the number of times that you send the post request. And this is not good, especially when you're handling cases like transactions. We need idempotency because imagine if you're to pay to a store and you paid 5 times because you refreshed or a certain error occurred. So you see there is a problem there, right? And it's really hard to cache them, right? So that's why we advise to also explore the patch, the put method, right? So going on from there, let's go to another slide. I think I touched a bit on these other methods, so people you're advised to use other methods. Okay, so another great thing or another best practice when designing a RESTful API will be the naming convention. Uh, so you see, because we are relying on the HTTP methods that are well set, there is the get, there is the post. We don't actually need to embed it into our endpoint again. By the way, endpoint is uh, just a slash URL. Let's say when we are analyzing this Google Docs URL, this full URL, so slash presentation is an endpoint that leads to other sub endpoints that are slash d slash this long string, right? So you have to get a resource from the presentation for you to have this page displayed. So since we are dealing with a REST API that utilizes HTTP methods, we don't need to actually write get again when we are designing our APIs. We don't need to do that. We can just write authors. And by the way, if you look at it carefully, you see there is a good naming convention that's here. Is we like to put things in plural, and I'm going to talk about it a bit later. Yeah, so it becomes really intuitive to someone when even to a developer, and it's a convention that has already been developed to use plural of what are these? These are nouns, right? We don't use a verb when we are creating our APIs because you see, get, add, these are verbs, they are doing something, but we don't want to do that because the HTTP method is self sufficient to tell us that if it's an add new user, so it means that it's a post method. A post method will be here. So we just need maybe a we need to structure this API into api.com. Instead of writing add new author, we could write like api.com authors. Then the method that is here would be post because we are posting. So it will be self-explanatory what we are doing. And when we want to get, because we're getting someone, we just put the get method because get method will be used when sending the request to our server. We don't need to actually add it into our naming when we are designing our APIs. Another thing is, yeah, I talked about the using of plural resources. It's just a really good practice, okay? And another great thing that we're going to really learn is the use of status codes. For a good documentation and a good API that you deploy for other developers to consume, the front end team, you really need to have your status codes very well thought out. So actually, they are very standardized. So you can just use the 200. 200 is very known because it is an OK status. So let's say you're just getting something. You want to make sure that someone is satisfied that they have gotten the thing, right? So it's a get request. So having a 200 status in your response body will be a great thing because it will show that okay, you have received the response. And 201 is when you're creating something. So you create something, you're adding a resource to the database. 201 is really helpful. 400 status codes, let's say around the 400 statuses are problems with the request that you're sending. 400, 401, 403, 404, all of these in the range of 400 are the problem with your request that you're sending. So when we look at 400, we'll see that this is a bad request and it is missing because it is malformed or missing request parameters because you can strictly define a lot of things in your backend when you're defining your when you're creating your REST APIs, so that someone needs to actually fill in some fields before they submit a request. And if they don't submit such information, the request will be malformed or missing parameters, right? And 401 is an authorization problem. So the person doesn't have the right privileges to access that resource. Let's say someone is trying to access the admin panel of your organization. They can't access it, and they'll get this error because they don't have the permission. And there is a fine difference between authorization and authentication, and we'll look at it. So 404 is very common. It's the resource is not found. And the 500, the range of 500 is for internal server error. These are unexpected errors, and we really try to reduce the number of um, 500 responses, because we need our APIs to be resilient. We don't want them to crash because of small things, right? Yeah, so something that had not been anticipated by the developer who was creating the API happened in the servers. That's why we got that error. So let's see another thing that we'll talk, that are the best practices about designing your APIs. So you need to know how to handle searching, pagination, filtering, and sorting. These are very important things for any APIs, because you can't just bombard someone with a lot of information at the same time. Even when we search for any resource, let's say API in Google, so it gets the request and then it displays for us a limited set of information, right? And then if we want more information, we'll click this. And you see, when I hover over this next, I get I get this endpoint that is search, then I enter, I find some more information here. These are query parameters that are used for pagination. So you see it is offsetting to the next page. So it is requesting a set amount of information instead of requesting for unlimited amount of information, or all the information that you have in your database. And you'll see that all the applications implement this, and that is pagination. Um, so filtering is the capability of getting only what you want. Let's say you want to, there are a lot of filters in a lot of sites, I believe you have seen. When you are working on a booking site, you want to be able to filter by a certain property, right? So you need to design them in your APIs, and sorting things. You can sort things by date, by time, by the order in which they were created. So these are very important things to consider when designing your APIs. Another thing that we're going to talk about is the API versioning. Whenever you see any documentation that is released out there, it actually has the URL as is seen here. Then you have a V, then a certain number. This is a version number that is used to really separate the type of version that is currently being used or consumed by the API. Because over the time, you will continue improving the API that you have created until it reaches a certain time. You see you have pushed the limit. You need to version up to another version that is more better and requires a significant change from the previous one. Let's say you're migrating your service from an XML data transfer to a JSON data transfer. It wouldn't be very logical to put them in the same versions. You can create version 2 for that and give people the experience of using JSON, so that they don't really confuse when they try to update to update from your references. When there is a major change, people love to add a number on top of the version just for good and safe measures. And rate limiting. Rate limiting is a very important thing, especially when you're building applications for scale for production. You can't just let someone abuse your site or access the information as they want. They can't just be sending a lot of post requests or a lot of get requests simultaneously. If you allow them to do that, they'll create a DDoS attack, distributed denial of service, because you don't limit the amount of times they can send requests. So there is a really special header that does that. So there is a in the header section of the HTTP call, there is the X rate limit, which you can set the number of of requests that a person can access in a given specified interval. It can be per hour, per minute. You can configure as how you like. And these are other parameters that you can set in your header body, right? In your header, not your header body. Um, you also need to have meaningful error handling, right? You can't just be writing weird error messages that cannot be intuitive to someone who is consuming your APIs. Like, let's say I'm requesting for a resource, right? I need to know if I've forgotten something. It needs to tell me that I've forgotten my a password parameter, right? Just imagine that it's giving you vague information that is not really useful. It makes the API really stressful to work with. So this is an information. So you see, most of the time we attach our information and hints in the message part of the body. We give it a status and a message, and these are codes for internal codes. Some really sophisticated APIs, when you see them, they have a status codes. When you're dealing with APIs from big providers like Google, you're dealing with the Google Maps API, it will give you a status code that you can further reference when you want to get more information about the error. And they can even add a more information, which is a useful link. This is a really good pattern. It's called Hatios for developing APIs. So in your documentation, oh, you can't just develop an API with no documentation whatsoever. How are people going to use it? So you need to have a bit of documentation in your API. If it's going to be pre-generated, it's going to be generated by Swagger. There's a popular tool for developing documentation of APIs. It's called Swagger. So it's here. Um, you can attach it into your API and it does the automatic documentation. And there is Open APIs, not Open AI. It is Open API. I was really confused at the first time. That's why I'm putting an emphasis. So you see, and we're actually going to be looking at Open API in a couple of minutes from now. We're going to utilize its documentation to actually understand our APIs that we created. Okay, so these are two main methods you can use to document your APIs. Um, Another thing that we're going to look at is, who has ever heard of SDKs, first of all, before we go any further? By a show of hands, guys, I need anyone to speak. I've been speaking for the longest time. Who has heard the word SDKs. Who has ever interacted with SDKs? Just someone who has played around, a bit curious, I guess. Guys, hello. Okay, Samson, you can speak.
I'm not sure whether you can hear me, right? Can you?
We can hear you.
Okay, so um, just this so we have interacted with things. So whenever you want to maybe make a query to open your key, you want to use those keys, you have to, if you use
Is it me or your internet is not good? I
basically whatever you're installing, whatever you're doing in AI. So basically that is the SDK. I believe that is what you wanted, Brad, right?
I didn't hear you actually, so I don't know if it's my internet or yours.
Bradley.
Hello, can you hear me?
Yes, I can hear you, but is that what you wanted?
I couldn't hear your previous request, so I'm just asking like, is it my internet or yours that is a bit
No, maybe probably mine.
okay? So
Can you hear me now?
can you please repeat again for a moment?
Okay, so I was trying to give you an example of what an SDK is. So basically, because ideally, sometimes you want to interact with other systems outside wherever you have viewers. And I'm going to give you an example of using OpenAI. So
Yeah.
whenever you want to interact with OpenAI, rather than you calling the APIs directly, so you basically have to install something like, if you're using Python, do something like pip install OpenAI. So basically, you're going to import OpenAI into your project, and then you can now use basically things that look like functions to interact with OpenAI. So basically, whatever you're using there is an SDK.
Yes, that's nice. That's really nice. At least someone has used it. Anyone else? Okay, let's look at SDKs and what they are and how are they different from APIs. So APIs are like building blocks, right? They're really small individual things. You can configure them to your liking, right? On the other hand, an SDK is like a proper workshop where all the development tools are already available. So they've already created the whole classes if you're using a class like API for Java and something like that. And they have already defined methods that can help you to interact better with their APIs. So they have already built for you a tool that is easier to manage than using their native API, that if they gave you their full API documentation to use, it would take a rather a tedious work for you to achieve what you would want to achieve. And it's a very repetitive thing that they can just create their own packages and ship them outside to make your life easier, because there is nothing better than making a developer's work easier, because they have a lot of logic to think about and other things, right? So multiple vendors, multiple people have APIs and SDKs. You just have to go and dig around and find out more about SDKs. SDKs are building blocks for what you want. Not a blocks, they are like a proper workshop. They have already created everything that you would need to accomplish that thing, bundled it up into one module for you to easily access it and manage whatever you're trying to do with their services, while an API gives you the fine grained control of each and everything that you want to do. So this is more fine grained. This gives you a bit of limitation, but it gives you a lot of generated functions so that you don't do it on your own. It's like trying to develop your own Instead of using a framework, popular frameworks for building an API, you develop everything from scratch. You start with the HTTP server, the native from your network library of the language of your choice. Instead of using the pre-built tools, you start dealing with the middlewares and all the complex things. So that's how SDKs are in terms of the differences between them and the APIs. So actually, let's move on and go to the GraphQL APIs. So actually, there are other recent API architectures and strategies that have been developed by people who saw shortcoming in the native REST APIs, because technology is always changing. So they came up with a GraphQL API, and it has also a query language. So what it does is it can sit on top of your REST API, or you can just use it as your barebone to fetch information as you want. But what makes it different is you request only what you want. Let's say you're building an e-commerce site, right? Just to render information, let's take one really good thing, like let's say Jumia, so that I can explain my concept very well. Just to render everything that exists here, you would need a lot of endpoints if you are to use a REST endpoint, right? But what if you could just link your database and create a query language where you could request the amount of data that you would in one single query. So if you wanted to display all of this with one request, you could do it by just adding the amount of parameters that you want and create a request to the backend. Another good example is GitHub. GitHub has a REST API, has a GraphQL API, right? I believe API. I think I can, yeah. So I believe this will understand this well. Uh, GraphQL API overview, authentication. So you see this query language and you see the type of data that they're requesting. You can request any amount of data that you want. Let it be 20 items from one request. That's just the basic idea. And it has its own upsides and downsides. So it's just one thing to actually know. And a lot of the people actually use it. It's also heavily used in Netflix for getting their data. Um, so it has, like I said, it has its caveats. So will not take a long time trying to explain it. You can just go and read this document on your own. I'll share it. So let's talk about a bit about uh, authentication and authorization before we go and take a look at a simple REST API for an inventory management system. Just to manage crude APIs of adding, deleting, and updating things. Okay. Then I'll try to explain how I've utilized what I've been talking about here, right? Um, so whenever you're deploying your apps in production, you should use TLS. That means that it should be having SSL, should be SSL encrypted with a TLS encryption. Um, most of the time nowadays, people love to use Auth2. with providers because they are way secure. So providers like Google, Facebook have a more secure infrastructure than you would when you're creating your own basic form of authentication. And whenever you're creating a service for anyone, and whenever you join a service like you're trying to access API keys, API services from vendors like Safaricom through the Raja API, you'll notice that they give you the API keys, right? For added layer of security and encourage good secret management for your APIs. So most of the time, it is very essential to never expose the keys in our code, but I underlooked that. I actually exposed mine, but it's not going anywhere in production. So you store them in a .env file or environment variable, and that variable there is depending on the provider, I mean on the hosting provider or hosting service, they'll give you a place where you can say securely store the keys so that they are not accessed, and you just reference them in your application. So you choose when to enforce authorization and request level authorization. Let's say you're having an application that cuts across a lot of people like managers. There are normal people who are just keying data, and there are other executives that look at the report. You will need to enforce authorization. Who needs to get access to what resource at the request level? And most of the time you leave that into the business logic. So I guess I'm going to heads up. I'll be using um, a framework called Fast API. It's a Python framework. It's a bit fast and it's better than, it has a bit of speed, and it is asynchronous in nature. So I'll try to start the service. Oh, there's a service here, but let me create one. One advantage of actually using this is that it comes built in with a asynchronous server gateway interface, that is the UVCon. For you who have dealt around with asynchronous uh, web servers, we all know that Unicorn is not an asynchronous web server. So the UVCon is more suitable, but I won't be demonstrating its asynchronous nature because I wanted it to be simple and understandable. But I just try to put it in the type of request that when you're making a request, it kind of is asynchronous. Because it's a simple app, this is the entry point. Um, this is where I'm instantiating my app object, and I've tried to divide my applications to different routes and different folders just for structure, and just put a simple slash, which is the default route, to just show a simple message that this is your first API. Hooray! There are many methods that we can use to actually interact with our API, but the one of the most advantageous thing of using this API, and I liked about it, is that it has its own documentation that they have already provided for you. Um, so let's see. Um, when you just go to localhost port 8000, we'll see the default entry. But one good thing is that it comes with open API docs, so we don't need to do any documentation. So we just go to slash docs and we get access to our open API documentation. So you'll see that it has documentation for each and every endpoint that we have created, right? And you can see at the root or entry when we call it, as we have seen without documentation, we are supposed to get the string. Hooray! This is your first API. Hooray! So, um, the good thing with this is that you can actually test your APIs from this GUI that they provide for you in the documentation. So you don't really have to open up any Postman, but you can always try with Postman, or you can also use a curl command, and they actually give you the curl command as needed. Like let's say in its documentation, it also shows you how you can get this request using a curl request, right? So if we copy this request and we just go to our terminal and we start a new shell, we can input it and run. Oh, curl is not supported by Windows. Oh my god. Oh, let me try and remove something. Yeah, it's the classic Windows problem. Uh, okay, but basically it should work. So now let's go and try to do basic things, okay? Because we try to register a user, right? So I believe that the most important thing for most of the services is that they have to have protected routes. So I created already a user that's called any user. Okay, let me just use one and any user one to create a new user. And when I hit execute, it runs. Okay, and here is the response body. We see that in each and every request, we have a code, a response code to tell us, right? We have a 201 showing that it is created, as I showed you in the documentation, that whenever you're creating a resource, you're adding someone to a database, 201 is your status code. And if you take this request into the terminal and use Linux, you would also call it through this command. Um, you would also try to go to Postman and use this request. It would do the same. This is just a better GUI for visualization, right? Okay, now that we have already created our user, password Mingori. Okay, any user one. Let's use the username to see if we can log in, right? And you see we're using the appropriate methods of HTTP. So we can try it out and just use our username, and the password will be password Mingori, right? And you will see that I did a form of authentication called JWT, which is JSON Web Tokens. So let me take a bit of time to explain what JSON Web Tokens are and how they work. Okay, let me go back to my code. and go to the authentication, right? I'm relying on the Jose framework for the first API. So what we're doing is we have defined our all these necessary things to secure our APIs. Secret key, I didn't put anything. Algorithms, it's good to use the SHA-256 because it's way secure. And basically, when someone passes in their password and username, we don't immediately save their password as they are. We first hash them, then we store them, right? Um, so how JWT actually works is that when you create a user or you create any resource, right? Let's say a user because it works with authentication, and I want to demonstrate the difference between authentication and authorization. Whenever a user is registering to a new application, right, or a new service they've never used, you're creating a new profile with a new email, or you're just creating a new email in the Gmail space, right? They actually have to add you into their database. And adding you, they need to have a way of actually maintaining your state and knowing that it is you who is accessing a certain route. When you once you're logged into your Gmail, you want to go to your inboxes, you want to go to your spams, they must know that it is you because I said REST APIs are stateless. So each and every time you need to be authenticated. One good way of authentication is JWT authentication. And how it works basically is it takes any data that they choose and use cryptography algorithms to convert that data. It can be your username, your user ID, it can be a combination of all those fields, it can be a private key that you want to use for more secure thingies. They take that, they hash it, and then they attach it to the HTTP header and they send it to your client. Your client is your browser, your client is your web app, right? I mean, is your front end web app or your front end mobile application, right? So when they send it through the header, it gets attached into either local storage, it gets attached to a session. There are these special storages that the browser API enables you to have them. Let me just show you a bit. Inspect, application. It gives you storage, right? You can have your local storage, you can have all these other storages. So what it does, it attaches itself there, and then each and every time that you make a request, you make it using that specified key, the JWT, I mean not key, token. So it's really secure. Oh my god, I've used enough. I've used a lot of time trying to explain, but I just wanted you to understand. And that is basically authentication as it is, right? You're authenticating someone, you're giving someone access to your service. Authorization is a different case. Authorization means that you're giving someone access to a specified thing because they have special privileges. Let's say you have an application that is being used by your manager, is being used by clerks who are feeding in data, and the data entry people. For each and every view, they need to have special authorization for them to use that specific route. And if they are not a manager, They cannot like get information like the financial statements, the projections. They can't get to the important information because they don't have the access, right? So that is the difference between authentication and authorization. Um, Actually, I don't think if I'll show you all the implementation, but you just need to have a way of connecting to the database because I told you that the APIs have to be stateless. So you need to store them somewhere, the information that you're getting from the user somewhere so that you can reference it later. You need to have a way of sending and receiving data. So those are the endpoints that you create, right? So for you can create endpoints for items, and you see the method is set clear. It's post, and it has items, not item. So this posts an item, right? This gets an item. This gets an item with a certain ID. So the difference between this and this is that this gets a specific item and this gets all the items, right? This puts, this adds information to the importance of using different HTTP method, right? This adds different information to an already existing item. Maybe you want to modify it, right? So this is what it's used for. This deletes, and so we have a way of changing the information, adding, deleting, and getting all of the information that are related to that item, right? Um, we use the basic. We create our own models, and we are using the SQL Alchemy ORM. So it's just a really simple implementation. And then the important and the most useful thing that I found when using this fast API is that it gives you a schema. It is more structured than fast API because it does validation on the fly, and it makes you use type annotations, which makes your code a bit faster. So as you can see here, I've annotated some types for my password. I've given them some constraints, and once these constraints are not met, it will throw off an error. Okay, and you can see here I'm also adding a custom logic so that I enforce it, so that if the length of the password is less than 10, I am sending a valuable error information message, like the things that I was telling you about, sending helpful messages. You can always extend it to your desires, and it is a very useful um, framework for creating APIs. I I didn't deal with like security for now because of the time limit that we have, but I believe that I'm open to a lot of questions that are coming in. I'll try to answer them uh, as they come. So, guys, you're free to ask any question. And sorry for taking up extra time. Hello, anyone who has questions? I believe that you guys have questions because I was talking a lot. I was trying to just demonstrate the power of the tool that I used. And anyone who wants to ask a question is free to join and ask a question. You can just unmute yourself So I think I'll stop sharing my screen. And if you want maybe to share your screen to demonstrate something, I'm allowing you to do it. So let me stop sharing my screen.
Bradley,
Yes.
I have a question for you.
Okay.
Can you hear me?
Yes, I can hear you.
Okay, so okay, you spoke about indemnity,
Yes.
and I thought you said that there was maybe one of the maybe put whatever method that can support independent. Which one was that?
Okay. All other methods in the HTTP of the HTTPs, most of them, almost all of them support idempotency as except the post method. The post is
Okay,
not idempotent. Okay.
You said it makes it it makes the API faster than the type annotation makes that API faster than REST API.
No, than other traditional APIs like the Flask uh, framework for using the APIs, just because it has the layer of type validation. So instead of actually sending the whole request to the backend for you to realize that it has a problem, when the request reaches, before it even starts going to analyze the data that is coming in, it looks, is this type correct? Is this type not correct? If it's not correct, it throws an error immediately before even going to line by line into the code. Let me give you a better description of what I'm saying. So let's say if we were to build a Flask or Django API, Django REST API, right? We would need to do a lot of checking right here, so that we check if it has the given thingies, so that we make sure that we are not going to get any errors, and we're not going to get any 500 status. It does not break our servers. We need to do the validations here. And this is costly because it starts reading line by line. Imagine it starts here. So whenever it is checking the user, it is calling the user object, right? It is already starting to consume some resources before we even do a type checking to know if the email exists. But when we have a schema, as the first API is, you define your schemas here. So whenever it doesn't meet the schema needs, it won't even go further. It won't even go to that specific URL. It will just get um, it will just get discarded from this area, and your error will be thrown from here because it uses Pydantic, which does the type validations. So even before it reaches the specific route to start reading the logic, it must conform to this contract, this schema, that is a method of exchanging data between someone who wants to interact with this API. They must have a username and they must have an email. So you can also do the email validation and make sure that it's a correct email. Maybe you want only organization email. You don't want a Gmail email. You can add a validator decorator and just create anything that you want inside here, and it will work accordingly. And I think I didn't demonstrate here. You see how it, all the things that I've defined are required somehow. The username, the email, the password. So if I was to put Let's say, you see, this is not of length 10. When you execute it, it won't even bother going to send the request. It will just tell you that the value must be at least 10 characters by default. So that's the advantage that I wanted you guys to see. That's why I used this fast API. And you can also see in our logs that there was no request sent. It was intercepted in the middle. They checked the types and the constraints, and it was discarded, and an error message was sent. Okay. Anyone else? Okay. Guys, come on. I know I did a shitty job in trying to explain some things. You can want to clarify, or you can ask a question. By the way, there are a lot of frameworks, and each framework has an advantage and a disadvantage to it. So you do choose your REST frameworks very well. So it depends on the ecosystem that you're familiar with and that you want to work with. You can work with the If you're familiar and you're comfortable with the Java language, there are plenty of tools for creating Java REST frameworks like the Spring Boot. It has its own REST APIs and its own pattern of creating REST APIs and other frameworks. Along the line, there is the Go language, there is JavaScript language, all these other languages. I think each and every language has its own simple way of creating REST API. So anyone who wants to add something that I've forgotten, to talk about something, you are welcome. To clarify on a certain point, to correct me. I've talked maybe some lies and you want to correct me. I'd really appreciate it. So is everyone content with the presentation? Because if no one is answering me, I'll have to end this session and end the recording. Hello?
Inasema session imekuwa fiti.
Okay, sawa. Okay, I'm stopping the recording.